Okay, there's another way of actually describing sets of real numbers, and this one's a little bit cryptic looking, so we have to sort of parse the ideas really slowly. But once you know how to decode the symbols, it really is not that bad. But let's take a look at one and see if we can decode it. So here we go. You see lots of things going on there. There are those curly brackets which indicate something's going on, making up a set. But here's how you read it. We start here with those curly brackets, and they always mean set of. And then here's this variable x. So it's the set of all x. And this vertical line means such that. We always translate to mean such that. So this is the set of all x such that this condition holds. Now, what's this condition? Well, this condition means that it's all the x's that satisfy this collection of inequalities. The x's are less than or equal to 5, and at the same time greater than or equal to negative 11. So if you were to read this out, we'd say this is the set of all x such that x is greater than or equal to negative 11 and less than or equal to 5. Now, what is that set? Well, that actually describes an interval. We can draw the interval if you want to see it on a number line. So let's mark negative 11 as being here. Here, let's say, so here is 5. 0 is probably around here. And so what are we talking about? We're talking about between negative 11 and 5. But which do we include in terms of the endpoints? Well, we actually include 5 because we have x less than or equal to 5, so we color in 5. And what about negative 11? Well, we have that x is always greater than or equal to negative 11, so negative 11 is one of the candidates we can have in our set, and so we color both endpoints in. This is a way of visualizing this set, which is described in set builder notation. Once you know the language, it's not nearly as scary as it looks. Just remember, you always start off with saying the set of all x such that this thing holds. All right, let's take a look at another one here on the sideboard. So let's express in roster notation all the positive multiples of 5. That means that we're going to use that sort of set notation using those curly brackets. But now I'm just going to list, like a roster, all the positive multiples of 5. So they're going to be 5, 10, 15, 20. Now that list goes on forever, so I'll indicate that with 3 little dots here. And then I close it. And that set actually represents the positive multiples of 5 in roster notation. Okay, now let's see if we can use set builder notation, so this sort of complicated way of writing sets, but very convenient to express this. Well, here we go. This is the set, so I always use these curly parentheses, of all x such that, and they have to be in between this interval. So the x's have to be greater than negative 1 and less than 2. Now, which endpoints do we want to include? Well, it's colored in here at negative 1. So I want less than or equal to here, but it's not colored in here, so I'm going to have this be x is strictly less than 2. And this is the set builder way of expressing that particular set. Being able to articulate and describe sets of real numbers will be really important, not just here together in this class, but in all future math classes when we want to talk about and express collections of numbers. Neat. I'll see you soon.